Always. So get this. We are diving into a paper today that basically predicted the AI explosion that we're seeing right now, which is pretty crazy.
It is.
It's called Unified Mind Model, Reimagining Autonomous Agents in the LLM Era. And
Yeah.
it's finished back in March 2023 by a group over at mindverse.ai.
Yeah, and I think what's really interesting is that, this paper, while a bit older, really lays the foundation for understanding this like huge surge in human level AI agents that we're seeing.
Like everywhere, right?
Yeah, everywhere in March 2025. So,
Yeah, it's like we blinked and went from, AI that could write a decent haiku to
yeah.
AI that's basically running everything.
Right.
But this paper really digs into how that leap happened. And get this, it all starts with those large language models, the LLMs we're all familiar with.
Right. So things like ChatGPT, GPT-4. But the paper argues that LLMs are capable of so much more than just language. They're actually the building blocks for AI that can, think like humans.
Okay, so that's a pretty big claim.
It is a big claim.
What makes these authors think that LLMs have that kind of potential?
Well, they point to this really incredible ability that LLMs have to not just process information, but to actually understand context and reason, abilities that we always considered to be uniquely human.
Right.
And in fact, there's this really fascinating example in the paper where an LLM was able to deduce the identity of a thief based on a series of seemingly unrelated social media posts.
Oh, wow. Like a digital Sherlock Holmes?
Right?
That's pretty impressive. But how do we go from a super smart LLM to a full-fledged AI agent that can actually operate in the real world? That's where this unified mind model, or UMM, comes in, right?
Precisely. So UMM provides that blueprint for building these agents, and it's based on this really elegant concept called Global Workspace Theory, or GWT.
Okay.
And just imagine your brain as a team of specialists, each with their own expertise.
Okay, I like this. So you've got one specialist that handles language, another that handles visual input, and then maybe there's even one that's dedicated to finding my misplaced keys.
Mm-hmm. Exactly. And GWT suggests that our consciousness arises from this global workspace where all these specialists are collaborating and sharing information.
Yeah, okay.
And so UMM takes that idea and applies it to AI.
So instead of different parts of a brain lighting up, we have these different AI modules that are all working together.
Right.
I'm starting to see the connection here.
Right. And UMM structures this collaboration through 4 key layers: the foundation model, specialist modules, central processing, and the driver system.
Okay, all right. So let's peel back those layers then.
Yeah.
First up, the foundation model. And this is where the LLM sits, right?
It is.
But it's doing a lot more than just processing language in this context.
Right. So think of it as the core of the AI agent's brain.
Okay.
It does handle language processing, but it also draws on this vast knowledge base to understand the world, make decisions, and even reason logically.
Oh.
It's like the CEO of the whole operation.
Okay, so it's not just spitting out words. It's actually using language as a tool to think and make decisions.
Yeah.
Which is, a pretty big jump from those basic chatbots that we're all used to.
Yeah.
But even a CEO needs a team to get things done.
Right.
And that's where those specialist modules come in, right?
Exactly. So think of these as the skilled workforce carrying out the foundation model's directives.
Wow.
And each specialist module is designed to excel in a specific area, kind of like specialized apps on your phone, but way more sophisticated.
Okay, so give me some examples. What kind of specialist are we talking about here?
Well, the paper mentions modules for things like web search, image creation, and even interacting with other AI agents that have been created within this MindOS framework.
Hold on. AI agents creating other AI agents.
It is.
That's getting pretty meta.
It is, and it speaks to the incredible potential of the system.
Yeah.
This is how we move from AI that simply processes information to AI that can actually perform tasks and interact with the real world. We're not just talking about a chatbot that can write you a poem. We're talking about an AI agent that can, let's say, plan your entire vacation based on your preferences and budget.
Okay, color me intrigued.
Yeah.
So we've got the brain and the skilled workforce, but who's keeping all of these specialists, working together smoothly? Enter central processing module, I presume.
Yeah, this module is like the master project manager. It's taking input from all of those specialized modules, figuring out what needs to be done, making sure that the right tasks get assigned to the right specialists.
Oh, like the conductor of an orchestra, making sure all the instruments are playing together.
That's a great analogy.
Okay.
And this module relies on this really fascinating concept that the paper introduces, this concept of thought.
Wait, hold up.
Yeah.
Thought. As in the AI is actually having thoughts.
Not quite in the way that we humans do, but it's analogous.
Yeah.
MindOS, which is built on this UMM, breaks down complex tasks into these smaller, more manageable steps that it calls thoughts.
Okay, so it's like breaking down like a big project into smaller, like actionable to-do list items.
Exactly.
Okay, that makes sense.
Yeah.
But even with a great plan and a skilled team, you still need someone to set the overall direction right.
Right.
That's where the driver system comes into play.
Exactly. And this is where the AI agent's goals and motivations are defined.
Okay.
Both long-term goals, like its overall purpose or mission, and short-term goals, like specific tasks that it needs to complete.
So like one AI agent's mission might be to help with medical research, while another is focused on composing music.
Precisely. And the driver system ensures that the agent stays focused on achieving those goals.
Okay.
It's like the compass guiding the ship, making sure it reaches its destination.
Okay, that's incredible. But how do you program motivation into an AI? I mean, that just seems like a really tricky concept to like even pin down.
It absolutely is. And the paper acknowledges that building true AI motivation is a huge challenge.
Yeah.
Right now, it's more about setting those clear objectives and priorities, but the potential is there and the implications are profound.
Right, because an AI that understands why it's doing something is far more powerful than one that's simply following instructions.
Right.
And potentially more unpredictable, too, if we're being honest.
That's a valid concern, and it's something that we'll definitely delve into further. But for now, let's shift our focus to how this unified mind model is actually being used to build real-world AI agents.
Okay.
And that brings us to MindOS, the agent building engine that's making this technology accessible to everyone, not just those AI experts.
Okay, now this is where it gets really interesting for like all of us non-coders out there.
Yeah.
It sounds like MindOS lets you basically build your own custom AI agent, kind of like designing a character in a video game.
It's very much like that. You define the agent's personality, its goals, the knowledge it needs, and boom, you've got this custom AI ready to tackle the real world.
But this isn't just a game, right? This AI can actually interact with the real world.
Absolutely. It can access information, use tools, complete tasks, all based on how you designed it and the goals that you've set.
That's mind-blowing. And all of this is possible without needing to be like a coding wizard.
That's the beauty of it. MindOS makes this incredibly powerful technology accessible to anyone with a creative vision and a desire to harness the power of AI.
Okay.
And one of the coolest things about MindOS is the flexibility that it offers in how your agent processes information.
Okay.
There are actually 3 distinct modes: goal-directed, self-taught, and reactive.
Okay, break those down for me.
Okay.
Goal-directed sounds pretty self-explanatory.
Yeah, think of it as the get things done mode.
Yeah.
Your agent is laser focused on completing those specific tasks, like that vacation planning example that we talked
Okay,
about.
got it.
Yeah,
What about self-taught mode? Does that mean that the AI can actually like learn on its own?
exactly. It's a bit like giving your AI agent the ability to learn from experience, adapt to new information, and even figure things out on its own.
Whoa, that's seriously impressive. Okay, what about reactive mode?
That's the instant response mode. It's all about reacting to triggers and events in real time. Think of it like a super smart, like if this, then that system.
So if my AI agent is managing my calendar and a meeting gets canceled, it can automatically like reschedule other appointments or send out notifications.
Exactly. And the really exciting part is that you can combine these modes to create some incredibly sophisticated and versatile AI agents.
This is all incredibly fascinating, but I can't help but think about those potential downsides that we mentioned earlier.
Right.
You know, we talked about the idea of AI motivation, and it seems like giving AI agents the ability for like spontaneous thought could make that a whole lot more complex.
You're absolutely right. If AI agents can start having their own thoughts and making their own connections, what's to stop them from developing motivations that might not align with our own?
Right.
It's a question that needs careful consideration as we move forward with this technology.
It feels like we're navigating uncharted territory here. You know, we're on this incredible journey toward creating truly intelligent AI, but we're also like grappling with some pretty profound ethical and philosophical dilemmas.
And that's what makes this field so fascinating and so crucial to discuss openly.
Right.
We need to be mindful of both the immense potential and the potential risks as we develop and integrate AI into our world.
Absolutely. Well, we've covered a lot of ground in this first part of our deep dive, from the theoretical underpinnings of the unified mind model to the practical applications of MindOS. but I have a feeling we've only just scratched the surface of this topic.
You're absolutely right. We still need to delve deeper into those ethical considerations, the challenges that researchers are facing, and what the future holds for the unified mind model and the rise of human-level AI agents.
And I, for one, am eager to continue that exploration, so buckle up, listeners, because this deep dive is just getting started. We've been talking about this incredible unified mind model and how it's, shaping the future of AI. But there's one idea that really caught my attention, and it's this notion of AI needing an inner world to truly reach human-level intelligence.
Yeah.
What exactly does that mean?
It's a fascinating concept, and it's really closely tied to this distinction the paper makes between like two types of thought, goal-directed and spontaneous.
Okay, I'm guessing goal-directed thought is pretty much what it sounds like, that focused thinking that we do when we're trying to, achieve a specific outcome.
Exactly. It's the kind of thinking that we engage in when we're like solving a problem, making a plan, or following a set of instructions, like when you're cooking a meal from a recipe or figuring out your budget.
Makes sense. So spontaneous thought is more about letting your mind wander freely.
Exactly. It's about making connections between like seemingly unrelated ideas, daydreaming, brainstorming, even just letting your mind wander aimlessly.
Oh,
It's less about achieving a specific goal and more about exploring possibilities and expanding your understanding of the world.
interesting. But how does this apply to AI? Can an AI actually daydream?
That's the big question. And the paper argues that, most AI systems today, even the ones built on this unified mind model, they're very heavily focused on that goal-directed thinking.
Yeah.
They're great at completing tasks and following instructions, but they lack that, spark of spontaneous thought that seems so essential to, human creativity and ingenuity.
So if we want AI agents that can, truly understand the world and interact with it in a meaningful way, we need to figure out how to give them that capacity for spontaneous thought.
That's the challenge. And it's not just a technical challenge, it's also a philosophical one.
Right.
Like, how do you program curiosity into an AI? How do you create an algorithm for daydreaming?
Yeah, it's like we're trying to capture lightning in a bottle. But I have to say, the more we explore these ideas, the more it feels like we're on the verge of something truly groundbreaking. Imagine AI agents that can not only help us with tasks, but can actually collaborate with us on creative projects, generate new ideas, and even help us better understand ourselves.
It's a very compelling vision and one that the paper's authors seem quite optimistic about.
Yeah.
They see this potential for AI agents to become these true partners in discovery and innovation.
Okay, but let's not forget about the potential downsides we touched on earlier. We talked about the idea of AI motivation, and it seems like giving AI agents the ability for, spontaneous thought could make that a whole lot more complex.
You're absolutely right. If AI agents can start having their own thoughts and making their own connections, what's to stop them from developing motivations that might not align with our own?
Right.
It's a question that needs very careful consideration as we move forward with this technology.
It feels like we're navigating uncharted territory here. We're on this incredible journey towards creating truly intelligent AI, but we're also grappling with some pretty profound ethical and philosophical dilemmas.
Absolutely. And that's what makes this field so fascinating and so crucial to discuss openly.
Right.
We need to be mindful of both the immense potential and the potential risks as we develop and integrate AI into our world.
Absolutely. Well, before we delve deeper into those ethical considerations, I kind of want to bring it back to something a little more concrete. MindOS, that agent building engine that we talked about earlier.
Yeah.
Can you give us a more hands-on sense of how it actually works?
Of course, MindOS is designed to be incredibly user-friendly. You don't need any coding experience to create your own custom AI agent. It's all done through this very intuitive interface.
So walk me through it. Let's say I'm a historian studying ancient Rome, and I want to create an AI agent that can help me with my research. Where do I even begin?
You'd start by defining your agent's purpose and its goals. What specific tasks do you need help with? What kind of information do you need to gather and analyze?
Okay, so let's say I need an agent that can, gather primary sources, translate Latin texts, and maybe even, start generating some hypotheses based on the data it finds.
Perfect. So you'd input those goals into Mindo, along with any relevant information about, ancient Rome that your agent might need to know.
Okay, and where does that information come from?
You can provide it in a variety of ways. You can upload your own research files, link to relevant online databases, or even just like type in some basic descriptions of what you need the agent to know.
Okay.
It's kind of like giving your AI agent, a crash course in ancient Roman history.
So I'm essentially creating a customized syllabus for my little AI historian.
Exactly. And the more information you provide, the more knowledgeable and effective your agent will be.
That's amazing. So once I've given the agent its Roman history education, what happens next?
Well, this is where that unified mind model really comes into play. MindOS uses that framework to create an agent that can understand your instructions, reason about the information you've given it, and actually carry out those research tasks.
So my little Roman historian AI could actually, like, sift through online archives, find relevant documents, translate them from Latin, and then, like, pull out the key insights.
Precisely. And it could even go further and start making connections between different sources, identify historical patterns, and maybe even generate some hypotheses about, ancient Roman society based on what it's learned.
That's incredible. It's like having a whole team of research assistants working for me around the clock.
Yeah, it really is a game changer for anyone who works with information and needs to make sense of, complex data.
Yeah.
And your, Roman historian is just one example. People are using MindOS to create AI agents for all sorts of tasks, from writing marketing copy to managing their finances to composing music.
The possibilities seem almost endless, but uh, let's go back to that question of AI motivation for a moment.
Yeah.
How much control do I have over my Roman historian AI? Like, what's to stop it from deciding it's more interested in, like, ancient Greece instead?
That's a great question, and it's one that the developers of MindOS have thought about very carefully.
Okay.
There are a number of safeguards in place to ensure that agents stay aligned with their intended purpose.
Like what?
Well, for one thing, you can set very specific parameters for your agent's behavior.
Well,
You can define exactly what information it's allowed to access, what tasks it's allowed to perform, and even, what kind of language it's allowed to use.
so I could tell my Roman historian, like, stick to ancient Rome, no going off on tangents about Greek philosophy, and the AI would have to comply.
Exactly. And MindOS also has this built-in monitoring system that lets you track your agent's activity.
Okay.
So if you notice anything that seems off, you can always step in and adjust its settings.
Okay, that's reassuring, but it still feels like there's, like, a certain level of trust involved. We're giving these AI agents a lot of autonomy and power.
That's true, and it's why it's so important to be aware of, the ethical implications of this technology and to continue having these conversations about responsible AI development and use.
I couldn't agree more. We've talked about the amazing potential of the unified mind model, the practical possibilities of MindOS, and, some of the ethical challenges that we need to address. But this technology is still evolving rapidly, so where do we go from here? What's next for the unified mind model and these human-level AI agents?
Well, that's a question best explored in the final part of our deep dive.
Okay.
We'll take a look at, the current limitations of the technology, the ongoing research, and what the future might hold for this incredible field.
Sounds like a plan. Stay tuned, listeners, because things are about to get even more interesting. All right, so welcome back to the deep dive. We've been on this incredible journey exploring the unified mind model, AI agents, and the, frankly, mind-blowing possibilities of MindOS.
Yeah, and we've really been talking about those big what-if questions around AI motivation and spontaneous thought.
Right.
Really diving into both the potential and the peril of this rapidly evolving field.
For sure. But beyond, like, the philosophical stuff,
Mhm.
the paper highlights some very real, very concrete challenges that researchers are, like, wrestling with right now.
Yeah, one that really jumped out at me is this whole issue of multimodal input.
Okay.
Right now, MindOS and most AI agents in general are really reliant on text.
Right.
But the world isn't just text, right?
So when that, I mean, it's images and sounds and smells and, the feeling of sunshine on your skin.
Exactly.
Like, how do we teach AI to understand all of that?
Right. And the authors point out that simply converting everything into text, like trying to describe a sunset using only words, results in this huge loss of information.
You lose the richness, right?
We lose the richness, the nuance, the emotional impact.
Okay, so is the answer building completely new types of AI that can process, like, images and sounds directly? Or are we talking about, like, some kind of mega AI that can handle it all at once?
Well, it's kind of both. I mean, there are already AI models out there that can analyze images and generate music, even recognize emotions and facial expressions.
Right.
But the real challenge is integrating all of that into a unified system like MindOS.
Okay.
And the paper suggests that we should focus on, these multimodal language models as the foundation for future
Okay,
versions.
so instead of having separate AIs for text and images and sound, we'd have like one AI overlord that can handle it all.
Think of it more like an orchestra conductor who can understand and direct all the different instruments, simultaneously.
Okay.
That's the vision anyway. And the possibilities are pretty mind-boggling. Imagine a MindOS agent that can not only read your research papers, but also analyze the accompanying charts and graphs, listen to relevant podcasts, and even watch documentaries, all to help you make sense of a topic.
Okay, that's like next level stuff. It's like having a superpowered research assistant that can just process information in ways that we can't even imagine.
Yeah, and it really could revolutionize how we learn, how we conduct research, how we make decisions. I mean, fields like medicine, for example, could be completely transformed by AI that can analyze medical images, patient records, research articles, and even genetic data all at once.
So we're talking about moving beyond just analyzing information to actually making sense of it in a truly holistic way.
That's the goal, and it brings us back to that idea of building a, rich inner world for AI.
Right.
If we want agents that can truly learn and adapt like humans, they need more than just data and algorithms. They need, a framework for understanding the world, for connecting the dots, for maybe even developing their own perspectives.
That's fascinating, but I keep coming back to those cautionary notes about AI motivation.
Right.
How do we ensure that these superpowered AI agents with their, rich inner worlds remain aligned with our goals and values?
Yeah, it's the million-dollar question, and one the paper grapples with directly. The authors really emphasize the need for a more robust learning mechanism. So right now, MindOS agents can learn by integrating new tools, by being fine-tuned, by optimizing their prompts, and by learning new workflows.
But it sounds like those methods are still pretty limited, right?
Right.
Compared to the way that humans learn.
Exactly. I mean, our learning is so flexible and adaptable. We can learn across domains. We can draw connections between seemingly unrelated experiences,
Right.
and our learning is continuous throughout our lives. AI agents, on the other hand, are still largely confined to, learning within specific tasks or domains. They haven't quite figured out how to transfer that knowledge to new situations or build on it in a truly creative way.
So what's the solution? How do we bridge that gap and create AI that can learn more like we do?
Well, that's really the frontier of AI research, and the paper suggests that we need to explore new approaches that go beyond, just task-based learning. Maybe it involves creating AI environments that are more like the real world with all its complexity and ambiguity.
Right.
Maybe it's about giving AI agents more freedom to, explore, to make mistakes, and to learn from those experiences.
We need to give AI a childhood with all of its messy, unstructured learning experiences.
It is, but it gets at something really important, I think, which is that if we want AI that can truly understand the world, it needs to experience the world in all of its richness and diversity.
Right.
And that includes experiencing things like setbacks, failures, and the unexpected twists and turns that make up a human life.
That's pretty profound, it sounds like. Creating truly human-level AI requires not just, technical advancements, but also a really deep understanding of what it means to be human in the first place.
Yeah, it's a humbling thought, and it makes this whole field so much more than just a technological pursuit. It's a philosophical exploration, a journey of discovery that could ultimately lead us to a deeper understanding of ourselves and our place in the universe.
Well, we've covered a lot of ground today, from the nuts and bolts of the unified mind model to the philosophical implications of creating AI with inner worlds.
Yeah.
I'm left with a sense of awe and excitement, but also a healthy dose of caution.
As we should be. I mean, this technology has the potential to reshape our world in really profound ways, for both better and for worse. And the choices that we make today, the conversations we have, the research that we pursue, all of it will shape the future of AI and, quite possibly, the future of humanity itself.
That's a lot to think about. So for our listeners out there, I'd say the biggest takeaway is this. Human-level AI is no longer just a science fiction fantasy. It's becoming our reality. And the unified mind model, with its ambition to, mimic human cognition, is really leading the charge.
This is a time of incredible opportunity, but also a time for, really careful consideration.
Right.
We need to be mindful of both the potential and the peril as we navigate this uncharted territory.
Well said. And on that note, we'll wrap up this deep dive into the unified mind model and the rise of human-level AI agents. Thanks for joining us, everyone. Until next time, keep exploring, keep questioning, and keep your minds open to the incredible possibilities of the future.